So, hello and a warm welcome to the fourth presentation in this little series. And in this video, I will describe the J4 assembly, which had some differences from the base design. So, J4. In the base design, the J4 housing, this square part, and the J3 spindle that basically went from this surface to nearly this surface, maybe to there, was two separate parts to manufacture them out of aluminium, and I simply combined them into one so that the assembly would be a little bit easier. I also combined the limit switch and motor bracket that was also mounted separately, and I redesigned the metal link that would normally link this assembly to the J4 motor, which is obviously this one here, this one, the J4 motor. And the J4 motor turns the J5, obviously. So to accomplish this, I had to drill a through hole for the M4 grab screw adjustment that adjusts the bearing space on this surface between the turret arm and the J3 bearing cup that seats on this surface, so it doesn't rub. In my assembly, I didn't have to implement some grab screws, so it didn't rub, but you might need to, so I did that. In the J4 turret housing and on the J4 turret housing, there are a couple bearings that seat on it and in it. So, and those were actually not imperial metric bearings, but metric bearings, because I firstly didn't have access to imperial bearings, but I also wanted to implement a different shaft from the original design. The original design had a 25.4 millimeter aluminium shaft or tubing, and I wanted to implement 25 millimeter steel shaft that was ground. And I wanted to implement that firstly because I had it on hand, and secondly because it is very readily available in every store where you can buy metal tubing. So because 25 millimeter, I think the wall thickness is 2 millimeter. Welded and ground steel tubing, stainless steel tubing is used in bath apparently, or in water supply, so you can just buy it by the meter, cut a suitable length together, and file the ends so that the bearings that go into the J4 housing don't get damaged while installing the metal tube. The metal tube is bearing on these 25-26 radial bearings, and on top of the tube we have two sets of axial bearings that get held in place via the J5 assembly, which we'll come to in the next video, and get preloaded via grab screws in the J4, what's it called? Timing hub. I also had to modify the timing hub from the original design. In the original design, the timing hub is also 3D printed. But in my design, I had to accommodate the slightly larger axial bearings. So that's why the teeth don't go right through it, but have to be disrupted. But the belt still fits on top of this surface and gets linked between those two. This belt is also one of the belts that got shortened by one tooth or two, I think. That's why I had to. That's also why I had to redesign the J4 motor bracket. But I wanted to redesign it anyway because with this method I could have full control over the tension mechanism, because the belt gets obviously tensioned via the distance of the J4 motor bracket to the J4 turret housing, and I just have to adjust the belt tension. I just have to redesign the J4 motor bracket and print it again. The pulley, which is not actually looking like that, but looking like this, has a flat spot so that it seats against the J4 motor spindle, and has two holes for heatset two heatset inserts, which are size 2M4. But I found that I don't really need them, but I still left those holes in place if you want to implement heatset inserts and make it more stiff. But you also have to build very small grab screws, because they can't stick out, because of course the M4 motor gets held in place via 4 M3 screws, which go into here, onto this surface. So that's the video of the J4 assembly, and now we'll get to J5.